Hey guys, welcome back. Today we'll be testing out this 2000 watt, 2200 watt hour Monstar portable power station. This power station was sent to me by the company, but that does not mean you will not get an honest and thorough review. If I see things I like, you're going to hear about it, and if I see anything I do not like, you're going to hear about that as well. I'm going to be performing several tests on this portable power station, so you know exactly what this can and cannot do. And I'm going to go through each one of those tests fairly quickly. First, let's take a closer look at the portable power station. Included with this portable power station, you're going to get this short instruction manual. It's only about 8 pages long. And compared to other manuals I've read, it's written fairly well. Included with this power station is this very large switch mode power supply. This is going to allow you to charge the unit using your AC receptacle, and you can see it's 25.5 volts DC output at 8 amps. And it plugs right over here into this jack. This is the power cord that plugs into the switch mode power supply. Also included is a car charger, plugs into your accessory socket, and the other end goes into the DC jack. With this unit, there is not an Anderson cable included for solar panels. You can charge using solar panels over here where it says PV in, or you can charge where it says DC in. We're going to go over how much current can go into these, as well as the voltage, later on. Over here you get your power switch, you have your LCD display. This turns on the AC receptacles. You have 3 polarized receptacles, and you can see there's an opening for the ground prong to go into on each one. Just like other portable power stations, you have your USB outputs, you have the Type C, and 3 Type A's. We're going to be checking the power output on all of these. This unit also gives you a marine grade, water resistant, even though the unit's not water resistant, 12 volt accessory socket. We're going to see if that's a regulated output. We're going to take a look at the voltage level with the unit fully charged, where it is right now, and then when the unit is fully depleted. We're going to see if the voltage level is fairly maintained. Current output for the receptacle is 8 amps. You also have the 2 DC jacks you see right over here. I can say the unit appears to be very nicely designed. You have this aluminum or aluminium housing along with ABS. There's bolts on top that hold these handles down so you can hold this in front of you like a cooler. These are stainless steel, and we can take a look all the way around. This is just an opening to allow air into the unit. Here's a look at the back side. Down here's the specifications, M2000. It's a 2220 watt hour battery. We're going to be testing that out. There's your AC receptacle, 100 to 120. We're going to see what the voltage is. Hopefully it's not 100, that's too low. Cigarette adapter, 8 amp max for the charger, and then all the specifications for the USB ports. And this end here, you can see the 2 fans, and they do appear a little small for a unit this size. You would think it would be like a big rectangular fan, but we do have 2 smaller ones. We're going to find out if these are sufficient enough when we do the 2000 watt continuous power output test. And right here you can see the Monstar power station looking straight down from the top. On the bottom of this power station are 4 large rubber feet. This power station uses lithium-ion cells. Now let's turn this on right here. Just give it a push. Battery, full charge. DC. DC out. That's now active. USB. And over here you push and hold. And now you have AC output, pure sine wave, and we're going to double check to make sure that it is. Alright, so let's get started by checking the AC output voltage. Keep an eye right over here on AC volts. Let's take a look at the output. 111. Okay, I've seen other power stations that I've tested that are in the 110 to 115 range. So 111. I would have liked to have seen it just a little higher, but 111 is not a problem. Now let's take a look at the output frequency to make sure it's 60 Hertz. Pretty good, 59.98. So the frequency is good and the output voltage is also good. Now let's take a look to see if this is pure sine wave. And here we have confirmation that the waveform is definitely a sine wave. For the next test, we're going to take this outside to see how well this unit can power high inrush equipment as well as power tools. For the first test, let's try out this 10 amp Porter cable air compressor. It has very high inrush current when it starts up. Perfecto, no problem powering the air compressor. And the cooling fan on the Monstar power station is running. Okay guys, let's try the Shopvac 6.5 peak horsepower. It says on the back label 12 amps. Let's see if the Monstar power station can start it up. Let's try it again. Okay, a 1500 watt microwave oven. That's working good. Okay. Let's see if this is hot. Oh yeah. All right, let me try it 2 more times to make sure there's no issues starting a microwave oven. Go. Started up fine. Fan just came on the unit. Let's turn this on 1 more time to make sure. Yep. So this turns on and off perfectly, and it's a 1500 watt unit with that power station. Rigid 15 amp rated saw. It has very high inrush current. Let's see if the Monstar power station can start it up. This one here is a little too much for the power station. Let's try it again. Second time it started it up. Let's try it again. So 2 out of 4 times it started. Okay, let's try something a little lower in power. Now let's try this 12 amp Eureka Upright. Not good, not good. Vacuum cleaners have very high inrush current. Let's do a reset. I'm beginning to wonder if I left the load in and then I reset it, if I'd have a soft start, because it seems like there's too much of an inrush if you plug it in while it's active. So let's do a reset. And if it does work, that would be a way to start up heavier powered loads, higher current loads. Let's give it a try. Okay, so that explains a lot. If you're going to have a problem starting higher current loads, what you want to do is plug the load in and then turn the switch on. Because right now if I try this, see? No good. So if I reset it with it plugged in, it will actually work with the soft start. So not really too bad because I was pushing it using the 15 amp loads. What I'm going to do is test out this section here first, and then when that's done, we're going to go back and I'm going to connect up 2000 watts or maybe just a hair under, and we're going to leave it connected to this unit when it's fully charged to ensure that this power station can maintain that load until the battery goes dead. Now the one thing about this unit that I did not like, let me put this on. When the load is running on the receptacle, there's no reading over here. It's not showing you how many watts are being used. I'm not a big fan of that. I like to know how much power is being used so I can keep it just under the maximum for the unit. This one here does not show you that. When the unit's being charged, it's the exact same thing. It does not tell you the input wattage. So let's test the USB section. Going to place a load on each one. just to see if it can handle what the manufacturer states. They say 2.1 amps for these three and 3 amps for the Type C. Plug this in. What I'm going to do is I'm going to turn the light down so it's much easier to see. There you go. So it's 5.2 volts right now coming out of that port. Let's turn it on. That's 1 3/4 amps. 4.7, that's good. We want to make sure it stays above 4.4. So let's go over here and increase. Put it to 2 amps. .6. Yeah, there's not going to be any issue getting 2.1. Yeah, minimum 2.1. Let's try 2 1/4. Yeah, now it's getting around. So these, all right, so this one here put out 2 1/4. Let's try the next one. Turn it on, make sure that one could do 2 1/4. 4.5, that's fine. Let's try this one at the top. Turn it on. .10 watts, 4.5. And you can see when I turn it on, it gives you an indication right here. See, it's now gone. So when you plug something in, even though it's not going to show you how many watts are being drawn, you're going to know the connection's been made because you're going to see, like right there, out 3. Okay. Now let's see Type C. Sometimes these will not work. To check that port, it has to be plugged into a device to actually have the output voltage set. So let's give it a try. And if it doesn't work using this load tester, I'm just going to connect up the MacBook, and then I'm going to place my phone and the load tester on another port and let it run for about a half an hour, just to make sure that everything works fine. Plug this in. Let's plug it into the tester. Nothing. There's nothing going on here. No. All right. And the reason for that is, like I just said, it needs to communicate. So let's try this to the MacBook. Put that on. If I plug it in the MacBook, you should see an indication if it's going to connect. Yep. See, now it comes on. Let me make sure the MacBook is actually charging. Let's see. Yes, there's an indicator. So it's definitely charging. Now let me connect up the other 2 loads. Plug my cell phone in now. I should see an indication up here. Let's see. Yep. And the phone is charging. It says charging. 19%. Push that off to the side. Now the load tester. Slide it over here. And turn it on. Fan's running. Okay. You can see everything is loaded up. I'm going to wait about half an hour, come back, and hopefully everything is still charging. While this test is going on, I'm going to turn on the DC section. And what I want to do is measure the output voltage for this socket as well as these jacks. Keep an eye on the digital multimeter right over here. 1323. Okay. Now let's measure these as well. I just want to make sure. 1323. 1323. When this test is done, we're going to hook up the load tester. According to the manufacturer, this should be 8 amps maximum, and that's actually 2 amps lower than the usual. Usually these portable power stations have a 10 amp output. Okay, it's been a half an hour and no problem at all. The MacBook is still charging, my cell phone, and I have the 2.1 amp load on the other USB Type A. Okay, the load tester's set up. 8 amps. Let's turn on the unit. Put on the output. You can see DC output. 1322. And now I'm going to turn it on. And we're going to leave 8 amps for about a half an hour. Here we go. A little bit of a voltage drop across this wire. We went from 1322 to 12.9. Current draw 8.006 amps. 103.3 watts. The 8 amp maximum rating is for the entire DC section. You have the 2 DC jacks as well as the accessory socket. Half an hour has passed at 8 amps, no problem at all with the power station supplying 8 amps. Turn this off. Okay, now what I want to do is connect up the switch mode power supply to charge this unit up fully. Amazingly, after all the tests I've done, the 5 bars are still there. So let me take out the switch mode power supply. I want to measure the output voltage that's going to be input into this unit. Right over there, you can see the switch mode power supply plugged in. This is going to plug into the unit. Let's measure the voltage. 26.2 volts. I want you to remember that for later when I go over the testing for the input section. And right here's the charging indicator. When it's fully charged, you're going to see all 5 and nothing moving. At that point, we're going to perform the 2000 watt continuous power output test. Right here you can see everything set up. I'm going to plug the power meter into the receptacle, which has the toaster oven and the hair dryer on it, and then the spotlight, which is 135 watts, will be plugged into the other receptacle below. Okay, let me tell you how it did. I had an average of around 1,920 watts that were constantly placed on this portable power station. When I started off, everything was good for about 10 minutes, running perfectly, and then all of a sudden it shut off. When it shut off, I immediately stopped my time clock. I waited, and about 2 minutes later, it powered right back up again. I started my time clock again. I waited, kept running, and once again, about 10 minutes later, it shut off. I stopped the clock, and then I started it back up again when it powered back up. This unit, even though it can supply up to 2,000 watts or even a little bit more, it cannot do it continuously. And the temperature of the room during the test was right around 75 degrees Fahrenheit. After stopping and starting 4 or 5 times at least, at the very end I added up the total runtime using that 1,920 watt load, and it was 1 hour. So that means the battery capacity, which is marked 2,220, I think, we came in just over 1,900, so it did come in lower, not as bad as other power stations that I've tested in the past, but the only thing is it just couldn't keep non-stop running using that 2,000 watt load. The output voltage was fairly stable, around 110 or 109, and when I got down to the very end, the last bar, it did drop to 103.5. Now 103.5 for electronics is not going to be a problem, but if you're going to be powering a motor device, you may have a problem if you go below 105 volts. Now let's go over the charging input voltage and current for the AC adapter, your car, and solar. This portable power station only allows you to use up to 30 volts. That I'm not thrilled with. I'd rather see it around 50 volts or 60 volts. That way you can use a solar module, 24 volt panels. They're forcing you to use a 12 volt panel for this portable power station. Turn the light off so it's going to be a lot easier for you to see the reading right over here. So that's what the AC charger output is, and you're going to see how many watts and how many amps right here. So let me plug this into the power station, and we'll have a very good idea how much power is going in. It's going to take a minute for this to level off. Okay, so right there you see 26.2, 8.3, and we're right around 220 watts. So if we're able to increase this to 30, which would be the maximum, let's see how much this goes up. Okay, so it's pretty close. The maximum input for this unit is just under 250 watts. When you have a portable power station of this size, you really want to see a minimum 300 to 400 watts. And the reason why, you want to be able to charge this much quicker. If you only could do 250 watts per hour, it's going to take you at least 8 hours, and you may not be able to get the unit fully charged in one day. But if you had 3 times 8 would be 24. The battery's just over 2 or 2200, so you'd be able to charge it much faster. The maximum input using the AC charger is going to be almost 250 watts. Now if you're going to be using your car, I'm going to reduce this all the way down to 12.6. Okay? 80 watts is going into this unit. One thing I can tell you is that even when this is nearing a full charge, you can still charge this using your car without the engine running. With the engine running at 14 volts, you're going to see the difference. Could be 14.2, that's fine. You can see you're about 10 higher. So you're almost 90 watts versus almost 80 watts. So that's what you're going to expect if you charge this in your vehicle. If you'd like to be able to charge as fast as the AC adapter, there is a way to do that, and I'll explain to you in 1 minute. Now, if you're going to be using this with a solar panel, this input right over here, the Andersons, are only rated for 100. But you're also allowed to use this jack with solar panels. So clearly, if you have just a 100 watt panel, you would plug it in here. If you have higher wattage, you'd want to use it here. But I need to explain something to you. So let me shut the light off, and I'm going to set this to the voltage of your typical 12 volt panel. Let's put this up to 21. Okay? Open circuit voltage, and of course if you loaded the panel, it's going to be lower. So you could see maybe 18. So you're only going to be getting like 115 to 120 watts. That's the absolute maximum that you can charge this unit with using a 12 volt solar panel. If you use a 24 volt, you're going to be exceeding the 30 volts input. Now there is a way to do it. If you take one of the modules you see right over here, it's a DC to DC converter. It can handle 8 to 10 amps. By using the DC to DC step up or boost converter, you'll be able to have your 12 volt solar panels. You can have 3 connected in parallel that can supply up to 300, even though you're not going to be able to put 300 in, but you'll be able to get almost 250 watts going into this power station. It would have been nice if they incorporated that into the unit, but it's a simple fix. It only cost about 10 or 12 bucks to purchase that DC boost module. Okay, with the handles removed, this should come off. And now we can take a look directly inside. And as you can see, there's not just 2 fans inside, there are 4. 2 pushers and 2 that pull. 2 of the fans are bonded directly to the heat sinks. The large circuit board sits directly on top of the battery pack. Over here you can see the wires coming from the battery pack to the main board, along with the fuses. And right here is the rear side of the control panel. I hope you enjoyed this video. If you did, be sure to rate thumbs up, share, and check out my extensive video playlist for many other videos of interest to you. Thanks for watching.